Good afternoon. How's everybody doing? Good conference so far? Very cool. My name is Ed Fisher, and this is a conference session on planning performance and bandwidth for Microsoft Office 365. Introduce my colleague William here when he comes up in a few minutes. What are we going to do in this session? We're going to talk about the connectivity requirements for Office 365, some of the things that are far too often out in the field overlooked or missed or misplanned for. We're also going to talk about calculating the bandwidth requirements. How do you know how much bandwidth your company is going to need to access Office 365? So that gives you an idea. We'll also have a pretty cool demo coming up as well. So let's jump right in. Connectivity requirements. What do you need to connect to Office 365? Well, you need network connectivity. That's pretty straightforward. It's an internet-based service, so connectivity over the internet is a requirement. How do we go around and how do we plan for that? A couple of things to think about when it comes to accessing Office 365. All access to Office 365 is encrypted. You can connect over HTTP. If you forget to type HTTPS, we'll redirect you to HTTPS. All access is encrypted. So what that means is you need to allow for that connectivity. We use third-party certificate authorities to issue our certificates. Our clients are set to do certificate validation. You'll need to allow that traffic out. Show of hands, how many people proxy? Okay. Do you allow outbound CHX, Krill, and OCSP? Because you're going to want to if you aren't already. We do use various third-party certificates. Our clients are going to do that certificate validation. Whether it's OCSP or CRL checking is based on the certificate authority, but that's all done over HTTP. If you don't allow the traffic, you break the clients. And the worst possible thing I ever get is, well, can I disable certificate checking because that's secure? Don't do that. Allow for that traffic. First and foremost, you have to allow for all the TLS. Apparently, I have a short range. There we go. Next is concurrent connections. Office 365 is not the internet. Outlook is not a web browser. We make connections, we make concurrent connections, we make persistent connections, and you have to provide an infrastructure that supports that. Again, folks who proxy. What do proxies normally control? Web browsing out to the internet. How do web browsers work? Well, they open up the main page. The main page has got a bunch of links to maybe a dozen different graphics, some JavaScript, maybe a little bit of CSS. They pull down all those little bitty 60, 80, 120 kilobit files, and then what do they do when they're done? They close the connections. How often are those connections open? A couple seconds. And then what do? They close the connections. So if your proxy's got a pool this big, it's shrinking and growing all the time when you're surfing the web, but there's lots of overall connections available. Who's looked at how Outlook connects to Exchange? Anybody looked at it from a packet trace? How many connections does a single Outlook client open to a single mailbox? What version of Outlook are you using? Well, if you're on modern Outlook, 3. If you're on legacy Outlook, 10. And how long does it keep those connections open? Well, if I come in at 8 a.m. and I log in Outlook and I don't go home till 5 p.m., it keeps those connections open the whole time. So that pool, if you're proxying, starts to shrink. It's not going to shrink and grow and shrink and grow and shrink and grow. Worse, what do proxies usually do when they don't see a connection close after 120 seconds? They close it for you. But Outlook assumes the connection is open because it's a persistent connection. So when Outlook goes to check for new mail, send mail, do a gal lookup, whatever it happens to be doing, is it establishing a new connection or is it using the persistent connection that it expects to be there? It uses the persistent connection. So if your proxy has closed the connection, what do you see? A little spinning circle. Outlook is not responding. Maybe a little pop-up. Outlook has lost connectivity to Exchange. After a couple seconds, it goes, oh, something killed the connection. Let me do a new connection. Oh, Outlook has reestablished connection to Exchange. If your proxies are killing connections too quickly, that's going to be a problem. You've got to allow for concurrent connections. And I keep walking away because I hate hiding behind the stage, but I just don't have the range. Modern Outlook. Office Pro Plus, Outlook 2016. At a minimum, you'll see 3 connections for a mailbox. Do any of you have shared mailboxes, delegate, delegatees, calendars, etc.? At least 2 for each one of those. You need to plan for those connections, and they're persistent. Open when you log on, stay connected till you log off. All right, we'll switch to the buttons. Sorry about that. All right, you also have additional connections for each of those. Again, plan for at least 2 for any delegated mailbox, any shared mailbox, anything like that. Again, on the concurrent connections, are you using SharePoint Online? Are you using Outlook Web App? You're going to see lots more connections for that. Are you looking at Skype for Business? You're going to see connections for that. So your infrastructure has to allow for the total number of outbound connections. Yeah, that's not bandwidth, but it's at least as important, if not more so. Because if your infrastructure, your proxy, your NAT devices can't support that connection load, you're in for a bad experience. Co-authoring is going to use more connections too. Does anybody use the Office web apps to co-author a Word doc, an Excel spreadsheet, something like that? These are also connections that we're going to use. Typically, if you look at any one client and their outbound connections, not at all unusual to see 20 plus connections. In a NAT pool, you've only got so many connections based on the number of IP addresses that are allocated to the NAT. Conservative, have 1 IP in your NAT pool for every 2,000 to 3,000 users. If everything is modern, Office Pro Plus, Office 2016, you can probably bump that up to 6,000 to 8,000 users per a NAT, but you need to allow for that. What are the bandwidth demands? Well, this is my favorite phrase when somebody says, how much bandwidth do I need? There are 3 things you can never have enough of: money, pizza, or bandwidth. Am I right? Show of hands. Anybody think you can have enough of any of them? Of course not. However, you can have enough to get by. Purpose of this is to figure out how much is enough from a bandwidth perspective. There are different clients that we want to look at. Yes, there's some bandwidth that's going to go into doing sync. Yes, there's some bandwidth that's going to go into doing authentication, but those are fractions of your consumption. How do we figure out how much we really need to allow for our clients? Well, Outlook, there's a calculator. The Exchange Client Calculator. Works really well, can tell you exactly how much bandwidth you're going to need to use. Easy to do. SharePoint, a whole lot harder because it's ever growing. As you move more and more and more stuff to SharePoint, you're going to use more and more and more bandwidth. But it's probably going to ramp kind of slowly. You'll see your trends. You'll be able to plan and upgrade for that. It's not going to be an all-at-once thing. Hey, I moved your mailbox, and now all of your traffic's up there. We're going to start implementing SharePoint. You're going to start using it more and more. OneDrive for Business. Same idea. It's very difficult to calculate because how do you put answers to questions like, how many files do you access? How many bytes of data are you going to change in those files on an hourly, daily, weekly basis? How can you calculate that? It's going to change day in, day out. But you can control it. The next generation sync client has bandwidth constraints for both uploads and downloads. So that's easy to say, I'm going to allocate X amount of bandwidth per user, and it won't exceed that. Skype for Business. There's a calculator. We're going to show you that here in a little while. It's a very cool way to figure out just how much bandwidth you're going to need there. Latency and latency tolerances are another aspect that it is, again, critical for you to plan for and be able to accommodate the needs. High latency is worse than low bandwidth. Give me a low, slow connection that's at least low latency, and all of the clients will work pretty well. Give me lots of bandwidth, but a very high latency, and that's where client performance begins to suffer. Okay, there are ways that you can address that latency. Cached mode. Everybody knows about Outlook running in cache mode? Great way to minimize the impacts of latency as well as consume less bandwidth. Use the cache. Constant repeated access to files that are in that OST file, they don't use any bandwidth at all. All you need the bandwidth for is the sends and receives of the net new mail, or searches for things that are older than whatever period of time your OST is set for. Most latency is either caused by on-prem devices and decisions, like show of hands, who's doing those proxies? Or poor routing decisions, or ISP peering or not peering properly. In other words, network. Things that you can control and things that you can fix. We can't speed up the speed of light. You can't pick up your office and move it closer to us. But the speed of light's fast enough. Your office is probably close enough to us. If you've got high latency, it's things that you can do something about, and we'll talk more about which of those are. First and foremost is name resolution. One of my favorite phrases, it was pounded into me by my old CNE instructor in 1994. If DNS ain't happy, ain't nobody happy. You've got to have your DNS resolution quick, responsive, close, local. It also has to resolve close to the clients. to get to the endpoints. If your DNS servers in that remote office forward to the DNS servers in the main office, well, then the resolution is going to come from the main office. If that remote office and that main office are in the same part of the world, United States, then that's going to be okay. But if that remote office is in Asia and the main office is in the United States, then we're going to resolve all of the endpoints to the United States. And if those clients are in Asia, they're crawling across the Pacific Ocean on the public internet to get to us, when they could have entered one of the data centers we've got in Asia specifically to provide close, local, fast, low latency connections. So keep your internet egress and your DNS resolution together as close to the clients as possible for the best performance. I keep walking away. Egress rules, firewalls. These are the things that you need to allow for. If you're going to control egress, do it at layer 7, not at layer 3. Do it by names at the proxy. Don't do it by IP addresses at the router or the firewall. Layer 3 doesn't scale. There are over 500 CIDR networks for Office 365. You really want to add every single one of those to an ACL to say it's allowed out? If you're going to control egress, control it by names. There's 40. Whole lot smaller, whole lot quicker. You need to permit all of the outbound ports that we need. Now, 99.9% of that traffic is going to be over TCP 443. Outlook, Outlook web app, SharePoint Online through the browser, opening documents through Office applications, instant messaging, presence, that's all TCP 443. But if you're going to do audio and video and desktop sharing, application sharing, those stream. We use higher ports. Skype for Business is going to use TCP and UDP. TCP for data transfers, UDP for streaming, 50,000 through 59,999. Also UDP 3478, that's all documented. You need to allow all that stuff out. If you don't, Skype will fall back to TCP, it will encapsulate in TCP, and that's where you get lots more latency. Let me another show of hands. Who's been on a voice over IP call and known it was a voice over IP call? Because you hear echo, you hear buzzing, it sounds like Max Headroom's on the other side of the line. Or you've watched a presentation and, hey, the slides aren't advancing, and then they advance really quick, or the mouse just kind of disappears and then it shows up on the other side of the screen. You know what's going on there? You're streaming, but you're forcing it to encapsulate in TCP. What's TCP do for packet delivery? Guarantees it. Reorders it. So what happens in a stream where you're doing an audio sample of, I don't know, 30 times per second, and one little packet in that stream doesn't arrive? Well, in UDP, it skips and keeps going. And since we probably audio sample our ears about 10 times per second, we barely notice it. But if it's TCP and that one packet gets dropped, nothing else happens until the timer expires and it gets retransmitted. And that's where you get the buzz and the chop and the max headroom and all of that stuff. You got to allow the outbound UDP to get your right performance. So now let's get to the meat, calculating bandwidth requirements. I mean, after all, that's the most important thing. You've got to buy the right size circuit. You've got to upgrade the right size circuit to allow client access out to Office 365. They're bandwidth calculators. Very cool, highly detailed Excel workbooks that, given real answers to the variables and the questions, can provide you some amazingly good estimates on what your client bandwidth is going to be. They exist for both Outlook and Skype for Business. We're going to share the Skype one in just a little while. Very cool. Very easy way to go, but likewise, they are good in, good out, garbage in, garbage out. If you don't know what one of the numbers are, don't guess. If you put a bad number in there, it's not going to give you an accurate value. Worst case scenario, take the maximum use case for every single one of those and assume every user is a heavy user, and you will have a not worse than. And the light users will mean it'll trend backwards. But the calculators are a great way to figure out what you need for Outlook and Skype, because those patterns are fairly consistent and fairly normal. They don't exist for SharePoint Online. They don't exist for OneDrive for Business because there's just too many variables to figure out. There's no way to figure out, because users' use of SharePoint Online, users' use of OneDrive for Business is highly variable from morning to afternoon, from day to day, from week to week. And a calculator needs some constants to plug in. Can't really derive those. So again, as I said earlier, SharePoint tends to ramp up. As you move more and more to Office 365, use will go up. OneDrive for Business, you constrain that. OneDrive is very, very good, the sync client, at only syncing deltas. So once a new file is synced, only the changes get synced, and that conserves bandwidth. But how much is a user going to change on any file there from day to day? That's why calculators are pretty tough for that. We had one, it was just not accurate enough, we pulled it down. All right, so moving on. Again, if you have valid data supply, the calculators are a great way to go. Don't guess, make it worse. I'd like to call up my colleague. This is William Looney. He is a principal program manager with Skype, and he's going to give us a demo of the bandwidth calculator. Thank you, William.
Over. So as Ed mentioned, my name is William Looney. I work in the Skype for Business team, and I manage many tools for IT pros to help manage call quality and other related features. And today I'm going to provide a demo of the Skype for Business bandwidth calculator. But before I get started, I want to show you some great resources about how to use and use the calculator, and some excellent guidance that we have delivered as part of the Skype Operations Framework. So this is at skypeoperationsframework.com. It's a whole collection of data or information about how to plan, deploy, and operate Skype for Business. And as it relates to the planning calculator, there's an offer in here called Determine Network Readiness. So it's part of what we consider a planning phase kind of activity. And underneath in here, you will find a very useful document called the Network Readiness Bandwidth Planning Calculator Guidance. So this is not just how to use the tool, but really some prescriptive guidance about some best practices to follow with the tool. I'll touch a little bit on that as we kind of go through the tool, but I just wanted to call that out. So skypeoperationsframework.com. So I'm going to open up the tool as you receive it when you download it. It comes with instructions and a user guide that kind of lists all the capabilities. And this bandwidth planning calculator was developed for Skype for Business back when it was Link, maybe back even as far back when it was in its previous names. And it supports all of the Skype for Business topologies. So it's designed to support on-premise customers. It's designed to support online customers. It supports customers who are on-prem as well. Oh, a little too big. So all of these complicated topologies, you can model and estimate bandwidth, the bandwidth needs for connections. The picture doesn't like being scrolled so much. You can model the bandwidth needs for your WAN connections. You can use it to model bandwidth connections out to your PSTN networks. So it's a very rich, complicated, or detailed tool to have all those different scenarios in here. So I'm going to kind of walk you through it in a little bit more detail. But it's a very powerful tool. So with power comes a lot of complexity in terms of configuration and choices. But I'll show you how it's relatively straightforward to kind of get an easy a starting point for the bandwidth needs for Office 365. There's a helpful Start Here tab. So this is the full flow of everything you could do with the tool. And the tool, as I said, covers scenarios for advanced users and expert users, but we're really going to focus on that first row. It's a little blurry. Yeah, let me make it a little easier to read. And that's really primarily on this top row. And this kind of gives you an easy way to model. Works really well for Office 365. And if your deployments or your needs are more complicated, then you may need to start drilling down into some of these other options. The tool, when you download it, comes with some predefined values in it. And there's a couple of things I'll highlight in the tool. Anything that's colored green is something that you can edit in any of the fields in any of the reports. Anything is yellow, you may be able to edit it, or you can edit it, but you probably typically want to leave it alone. And if it's red or it's black, grayed out, there's things you just don't want to touch because it's not something that you can change. So the concept in the bandwidth planning calculator, there's a lot of rows on here. Just as a sense, I'll show you one of them that goes into triple digits to to the side. So it's a really complicated, Excel spreadsheet. But the core concepts is you define your personas. You define kind of the characteristics of your users. That's a little better. So you define, you can label them, give them a name. You identify which kind of client they're using. Are they an on-premise user or are they an online user? And then you have these ability to kind of tailor, are they a heavy user of various workloads? If you know your users are extremely heavy instant messaging and presence and don't really use conferencing, you have the ability to kind of create this persona that matches that. And the spreadsheet will then compute the bandwidth needs based off of those models. So there's a tab here with a series of personas. Generally speaking, you don't need extra fine detail. You don't need 100 different personas. The tool only supports 10. You can get very accurate kind of approximations with just 1 or 2 personas. But it really kind of depends upon the nature of your business and your needs. There's lots of data, and we'll kind of go through a few of these key columns here in a little bit. So you define your personas, and the next piece, excuse me, the next piece is the definition of the sites. So the sites are kind of the core concept where you're kind of mapping your network topology into a few kind of concepts. You have your central sites. In a Skype for Business on-premise deployment, this is where the Skype for Business servers are. But in Office 365, this is where you've got a large you've got a number of users at a site, and they have internet connectivity or internet egress connectivity directly from that site. And then you have the concept of branch sites. And branch sites are sites, typically smaller number of users who will, depending upon your topology, have a WAN connection to your main site or your central site, and you may or may not have internet egress. And the calculator can then, depending upon how you configure it, can compute, for this example, the user in Tucson, if they were connecting out to the internet via Phoenix, the tool would calculate the WAN connection and the WAN bandwidth used between Tucson and Phoenix for that internet egress traffic. So all of that capability is in the tool. It has detailed reporting out. So many rows, it likes the 70% setting. It'll give you a breakdown of all the different sites. It'll show you, how much bandwidth is being used for all the different Skype for Business workloads. So you can kind of see, is most of my bandwidth going to audio or video, or kind of how things fit. And then it'll also break it down across WAN connections and internet egress traffic. And I'll kind of walk through all of those capabilities. There's some charting in here, some macros built in. It is a macro-enabled Excel script, so you'll need to make sure that you accept the little checkbox that says, allow macros for this. But you get some visualizations of how much bandwidth your model is predicting you use versus how much you've said is allowed, and that then allows you to identify weak spots in your network or networks where the bandwidth needs are ahead of maybe what you have capacity for. And then there's some other deep things in custom and configuration. You can notice lots of reds and yellows, which are kind of things to maybe you don't want to get into this depth, but it is a very rich, powerful tool. So this is the example that comes downloaded. So it comes preloaded with these kind of personas, but I thought it'd be easier to show kind of a walkthrough of a demo with a empty one. So I went ahead and just zeroed everything out. I made a copy. I thought I had zeroed everything out. So again, the workflow starts off with define your sites. But in order to really define your sites, I like to start with double checking the definitions. And there's at least one in here that I kind of like to change, which is the application sharing resolution. The tool has been around for a very long time, and these days many users are up using 920 by 1080 resolution. So this is a box that, if that's what most of what your users are, this one's a good one to set to kind of get the application sharing bandwidth correctly. And then we can go in and create a persona. So let me just go ahead and walk through these columns. Yep. And if you try to change something that it's unhappy with, it's a protected sheet, so it's going to pop up a little message and say you can't change it. So it's hard to put anything in the tool that will break it, but it is possible to things that maybe don't make as much sense. So, I'll say IT worker. and I'll say that they're part of O365. So this is just a label. And I'll pick a client, and again, this tool supports lots of different flavors, but I'll talk about Skype for Business. And the client is used to look up what codecs the client support, so it kind of helps model the underlying audio and video technologies correctly. Then I have the choice of which deployment, whether this is an on-premise Skype for Business deployment, or am I talking to Office 365. So if Office 365 is online. And then I have the choice of setting, how heavy, are this a low IM and presence, medium, high, custom, a lot of flexibility. For these kind of things, as a starting point, if you don't have anything better, medium is a relatively good starting point for these values. If you don't know better, it kind of gives you an order of magnitude. I'm going to just skip this RT value. RT video type is probably not super interesting for this, but I'll just set it as step. Remote users is what percentage of time is this person or these users expected to be working out of the office or working out, maybe out from their home or some other field. So this is a percentage, so like 20% represents 1 day out of the week. So out of the 5-day working week. So let's just say maybe every other week they're going to work from the road. So set it as 10%. What percentage of time are they going to use stereo audio? I'm going to say 0. It's a very narrow feature. We can just zero that out. Let's see. Video quality, I want everyone to say that they're going to use the best video quality. And then typical is a great value if you don't know any better. And typical, and then you get the option of setting the PSTN termination or the connectivity solution that you're using in Office 365. None if your users don't have PSTN connectivity, but let's say these users have PSTN connectivity, so they have the full PSTN calling E5 license, and I'll just go back and rename, adjust the name. So now I have at least one persona defined. And now that lets me then, I can start going in and defining my sites. So let's say I'm going to start, my company has, let's say, 2 sites. I've got a site in London and a site in Cardiff. And I know my Office 365 tenant is hosted out of Amsterdam. So I just put that in as my Office 365 site. And the tool allows you to have multiple sites depending on your topology, but let's kind of start off simple. So I've got London and Cardiff, so those are my sites. And right now you can see it's saying 0, no users. Oh, I can see, maybe I'll zoom in a little more. There's no users set, because I haven't told it the users and the profiles. The next 2 columns help define the sites in terms of helping define the topology about which is the O365 site that's providing the services. In other words, where are these, what's O365 site is hosting the tenant, and then where is that site getting internet egress. So since I'm going to just keep it simple and just have a single Amsterdam site that my users in London are going to connect to. And London has its own internet egress, so I just say internet egress from London. And a bunch of gray columns that you can simply ignore. And we're going to skip over the WAN link at the moment, and we'll get back to that. And let's just say London's got a, 10 megabits per second link. It's not really big at the moment, and we'll come back. And now I can go through, and I have the ability to set 3 different personas that apply to that site. So I've only defined one, which is my IT worker. Oops. And now I can say how many users at that site. So let's just say, I was crazy. I have this really small link, and I've got 20,000 users there. And I could, if I had more personas, I could keep going and adding over and over and over those 3. And just as a sign of the complexity that it takes to compute bandwidth in Skype for Business, so let's see, we're in column GQ. Doesn't quite go that far. Out to ADN. So this is one of the few spreadsheets that you'll actually get the triple letters for your columns names. It's very exciting. So let's go back. This one, there we go. Okay, so I've defined my London site. Now you can see that the gray number's populated. It's got the 20,000. So I've got that site defined. And before I add the Cardiff, I can go and take a look at my aggregated results. Again, let's zoom in a bit. So the very first table is showing you your WAN traffic from the central sites. And as defined, I haven't really set up any of the WAN connections, so we'll skip over these sections. Here, because this is an Office 365, this last section is really interesting because this is talking about how much bandwidth is needed for that egress out to the internet. So this is the 10 meg internet setting that I had configured on the previous site definition. And then here's the breakdown of bandwidth going across the internet for those different workloads. And you can see here I need 306 megs, so I'm slightly overutilized. I'm going to guess the users are going to have a little bit of a quality problem with that one. And you can also see one of the new recent additions was the tool was this Cloud PBX feature. And that then now we have this internet PSTN bandwidth number. So that's consuming 55 megs on its, 55 megs on its own. So I'll go back. Oops, it was a typo. I don't really have 20,000 users. I have 200 users, so we'll scale that down a little bit. And now that I've got my London site, now let's deal with Cardiff, because I like Cardiff, and we're gonna make sure the users have a great experience. So Cardiff is a branch site. So I'll go into Cardiff and I'll say, okay, well, they're hosted out of Amsterdam with the rest of my tenant. But Cardiff, unfortunately, we haven't been able to have direct internet egress from that site. So I come in here and say internet local insight. Internet local insight. Take that back. Sorry. They don't have internet egress. I pick London. London is the site that they're egressing to the internet from. So all of the traffic from Cardiff first goes to London, then goes out to the internet. I only have one site like this for now, and I can basically, now I need to go pay a little attention to my WAN connection. So let's just say I've got a nice, 100 meg pipe on London connecting it to the WAN, and maybe only 10 of that's going to Cardiff. We'll say like maybe 30% for the dedicated for the for real-time traffic. So this is basically all the media, all the Skype for Business traffic typically will be sitting in your RTC queue. And you can see I don't have an option to set any internet egress bandwidth for Cardiff because I told it we don't have an internet connection there. But I do need to tell it how many users are there. So I pick a persona. I can pick the same user profile, or I can pick different ones. And I can say how many users are now. And now the spreadsheet will have auto-updated. And a couple of things we should see. Now we start seeing how much bandwidth is getting for the WAN connection. We see how much bandwidth is traversing into London for this, what we call inter-site peer audio. So this is the audio now coming from Cardiff to London to egress out to the internet. More data about that. And my overall internet access, my bandwidth here at London has now, I kind of still went over the budget. But the numbers here at London now account for not only the London users, but now also the Cardiff users who are egressing out from there. And now I can go to the graphic tabs, hit update. Oops, why are you unhappy? What did I say? You need to click the enable content button. So there you go. Proof in progress. You do need to click that button. Click to update the tables. This just kind of cleans up, so it's just some Excel processing to kind of get things neat. And here you can see information about how much bandwidth is being required versus how much is available on those WAN sites. How does the WAN connection of the branch site on Cardiff, right? I set it to use the RTC to be about 3 megs, and we're only using about 1.8 of those megs for all the real-time traffic. And then you get a report at the end that kind of shows you which sites are exceeding or having issues. And that kind of gives you a quick overview of how to plan and bandwidth for Skype for Business with the bandwidth planning calculator. It can feel a little intimidating when you first start. I know I also felt intimidated just getting ready for the demo and trying to figure out what were the right things to show. But I think I've shown it's very easy. It's easy to kind of get those initial approximations to get you started. And you should definitely look at the guidance that we provide for how to use the calculator and the recommendation as part of the Skype operations framework. It's a very hands-on guide, giving you guidance specifically around Office 365 and guidance about what are some of the best tips and tricks on trying to make sure that you get an accurate estimation of bandwidth. So thank you. And with that, I will hand it back to Ed.
Thank you, William. 5. Yes, sir. Thank you much. Good job. Pretty cool stuff. definitely follow the guidance. This is not simple calculator, 2 + 2 = 4. This is like 2 cosine pi r squared tangent stuff. 7 pages, lots of numbers you need to feed in. Again, being accurate will give you accurate results, and that's really what you want to do. But what if you don't have time? Don't have time to go through that. Don't have all the information. Need a number. Boss wants it by this afternoon so he can get budget approval for circuits. What are other ways we can go? I've been doing Office 365 deployments now for about 6 years, and I was a customer for 2 different enterprises before I came over to Microsoft. These approaches come from a combination of what I've done myself, what I've done with other customers over the years. One valid way of doing it is what I like to call the overestimate approach. Hey, you've been looking for a reason to upgrade circuits anyway, so gonna need that, round up to the next random number, and away you go. A little more accurate than that. Take your current budget. Take your current bandwidth figures. If Exchange is in your on-prem environment, you've got NetFlow. If you don't have NetFlow, you've got a switch, run top. You can use Perfmon on Exchange. Take a look at your client. When you move Exchange from on-prem to Office 365, the amount of client bandwidth that you need doesn't change. It just extends from your WAN and out your internet to the cloud. So you can look at the amount of bandwidth coming in and out of your Exchange infrastructure and just extrapolate that out. You're not going to use more bandwidth from your clients going to Office 365. You might even save some bandwidth if you switch over to Exchange Online Protection, Advanced Threat Protection, let us do all the message filtering. You'll buy back some of that internet bandwidth of the 80% of spam that you're having to drop at your edge. So start with that. You look at the SMTP traffic again, you can buy back some more bandwidth. You can use your current bandwidth figures for SharePoint as well. Again, Perfmon can tell you how much client traffic's going in, top, NetFlow, various statistics from your network. Figure out how much you want to allow for OneDrive for Business. You've got 500 users, you want to give them each no more than 100 kilobits per second for sync traffic. Do the math, extrapolate it out that way. Round up to the next random number. I mean, round up to the next circuit size that your ISP will sell you. That's a good way to go. Provides you some headroom. Allows you to expand that way. I want to photobomb some of you guys. You guys know the slides are downloadable, right? So I'll keep going if you haven't got a picture yet. If you wonder what we do, this is how we do an office. We take an office, we look at how many people are going to be in the office. We average 400 kilobits per second for each user in the office, with an expectation that the number of people in the office is going to grow by another 50%. So if there are 100 people in that office today, and we're going to provision a circuit, we're going to do 150 times 400 kilobits per second for their bandwidth. Now that's for more than just Office 365 services. And of course, it's Microsoft. We probably have a little bit more budget we can spend on the WAN than some of you do. But this is what we do. You may want to cut that in half, go 200. Cut it by a quarter, go 100. But if you're looking to estimate, plan the number of users with growth so that you make sure the lead times for your circuits allow you to go. Looking back over the 6 years, talking to customers, hey, what was your bandwidth like before? What was your bandwidth like after? They average about a 20% increase. That's for Exchange Online in day one, ramping up in SharePoint, deploying OneDrive, deploying Lync or Skype, depending upon how far back these customers were. 20% is about the sweet spot. There's a full recording on Microsoft Virtual Academy where I break down 7 case studies of those customers, talk about their befores and afters. If you go to Microsoft Virtual Academy and you search on my name, if you want to see some more of that specific breakdown and where the 20% came from, please check it out. It's about an hour of your life. But the overestimate approach is a good way to go if the boss wants a figure today because he or she's got to do a budget estimate. You can also do an extrapolation from pilot. I've had several customers do this with really good success. You take your pilot users. You look at what bandwidth you're using before you start. You build a pilot that's more than just IT. Have some people from the business because, I mean, we're all IT. We wouldn't be in here, right? How heavily do we use mail? How often are we in SharePoint? How much are we doing audio and video calls? Probably a lot more than other users in the accounting department, the finance department. You want to have some of those users as well. Get a good representation from your pilot. Take a look at your circuit utilization before, run your pilot, look at the increase after. If your pilot group was a good representation of reality, it's going to be a linear extrapolation. If 10 people bumped up 1%, 100 people are going to bump up 10%, 1,000 people are going to bump up 100%. That math is held again and again and again, as long as the pilot population was a good representation. If all of your pilot folks are going to be IT folks, you're going to be on the high side. And it's better to overestimate than underestimate when it comes to getting bandwidth or pizza. There are some things that you may choose to do, may be forced to do, security may require you to do, that will hurt performance. Keep your eye out on these. It doesn't matter how much bandwidth you've got. What's more important than bandwidth? Latency, excellent. Yes, so keep an eye on these things. Latency is going to hurt a lot more than bandwidth. Your performance will suffer no matter how much bandwidth you've got if latency goes too high. Spoken Hub Internet Egress. There are a lot of times where you're going to have to do that, either because of budget or security policy or availability. It can work very well, but it's not the optimum starting point. If you can do local breakout, you are a lot less likely to run into the latency of routing traffic from that remote office all the way to the corporate office or headquarters data center and then out to the internet. Bad DNS forwarding, especially if you are multi-regional. How many of you are international? You have offices in North America, in Europe, in Asia, and South America. You want your DNS resolution and your internet breakouts to be together and as close to the users as possible. Don't put one right next to the user and the other far away. Keep them together so that wherever you're getting out to the internet, you're getting into us as quickly as possible. And that means you want to resolve the names where you get out to the internet. But if you can keep that as close to those offices as possible, you get on our network, and our network is only Office 365. No cat videos, no binge watching Orange is the New Black, none of the other stuff on the internet. You get a much faster connection. Proxy. Lots of people have to proxy. I get it. Security mandates it. There are right and wrong ways to do it. Just about every major proxy platform on the market today supports whitelisting. If you have to proxy our traffic, whitelist our traffic so that it is allowed through as soon as endpoint evaluation takes place. It's all encrypted. What are you going to get trying to inspect encrypted traffic? Not much. So what's security's answer to that? TLS cracking. How many connections is the average user going to have to Office 365? Anybody remember the number? So if you're going to do TLS cracking, how many computations per user does that proxy have to do? Well, 40. It's got to terminate the TLS at the proxy and establish new TLS out. So how many connections are most proxies going to be able to handle? Put on top of that all of the maths to do all of that TLS calculation, and you wind up with the proxies choking. They don't typically have the capacity to do it. You can absolutely deploy proxies with sufficient capacity. I have customers who want to inspect everything. That's their requirement, okay, and they're dropping a couple $1 million on their proxy infrastructure. If that's what they want to do, they can absolutely do it. But if you built a proxy infrastructure for web surfing, and now you want to put access to Office 365 to that, I promise you, you're going to have a scale issue. So please avoid the proxy if at all possible. Whitelist it if you can't. Yes, I know sometimes they don't like it. But if they're not doing TLS inspection, take a packet trace and show them all that proxy is a very expensive router. Because we're all TLS. So if you're not doing TLS cracking, what's going through the proxy? A bunch of HTTP connects. What's the proxy seeing other than the endpoint? Nothing. It's all encrypted. You're not getting anything but extra latency out of the deal. So always, always, always be aware of TLS inspection. That can crush performance. Okay. You should properly consider Office 365 as an extension of your infrastructure. It's not the internet. The things that security wants to see at the proxy, there are lots of other places they can see that already. Host-based endpoint protection, egress filtering, ingress filtering. If you're going to route all of your email messaging through your on-prem hygiene solution, then you've already got that. We run full anti-malware in the system. What are they getting by looking at that point where the traffic goes through the proxy? It's belt and suspenders. Some policies require it. You can certainly do it. Our clients will work with it, but you've got to scale for it. And again, getting onto our network as close as possible is the right way to go. If your egress is remote, if your DNS is in the wrong region, that will greatly crush your performance. Okay, and again, always watch your proxy for performance. Keep an eye on latency, keep an eye on processor and memory utilization, watch your windowing. Going a little deep, everybody know what TCP windows are? How much data we can send before we have to stop and wait for an ACK. We'll start with the window scale factor of 8. Take a trace, see the responses coming from the proxy, and the window scale factor is 2 or 0. The proxy is overloaded, and performance is greatly impacted by that. And again, if you're going to do TLS inspection, prepare to spend a lot of money to be able to do it at scale. So let's wrap it up so we can get into some questions, because I'm sure there are folks out there who've got some questions, and we want to leave as much time as possible for that. Okay. Low latency, far more important than high bandwidth. Yes, bandwidth is important. You want enough bandwidth, but pay more attention to keeping your latency low. Connectivity requirements are documented. There's lots of good information on TechNet and support.office.com. Please read that. Endpoints are not a la carte. They are, here's the list of all the endpoints, allow them all. Port requirements, they're not a la carte. Don't pick and choose between them if you want to support the service. Allow the outbound connectivity. The calculators are great when you've got good baselines. Again, the second approach, if you don't have good baselines, go worst case scenario. Overestimating your increases is a very valid approach. I've seen a lot of customers with great success over that past several years. And a pilot could very well be the best way to go. The only issue with the pilot is if you determine you need more bandwidth, what are the lead times from your ISP? The pilot can tell you, hey, to go to full scale, we're going to need to double our circuits, and your ISP comes back and says, sure thing, I need 6 months to provision those. You probably want to get started with an estimate before then. And then there will always be new services. There will always be new features. Office 365 is evergreen. We're constantly upgrading. We're constantly adding new services, new features. You may not want to take advantage of them all at first, but you probably will at some point. So again, plan for growth. They will drive the need for more bandwidth as we go. And let's see. If you would please use the microphone so that we don't have to sit there and repeat all the questions, but I would love to open up for some questions now.
I totally understand the point about the proxy. We have seen enough packet traces recently to vouch that it's valid. I would question, however, what is the better way to do it from your perspective to get a very, very thin proxy solution still that does whitelisting or whatever, with the advantage, I think, being that you can actually put in the pack files host names and not network routes.
I'm sorry, what was the very last thing you said?
The advantage, I think, of going with a proxy still, even if it does very little, is the ability to publish in the pack files by URL, by matching, and not by IP address. The other option being probably to publish routes into the environment, which has a question of how many routes. Is that list, persistent, static? Is it dynamic? Do I need to do BGP peering, and so on and so forth?
So our guidance, if you are going to deploy any proxy solution, and yes, the internet's a dangerous place. I'm not saying throw out your proxies, don't proxy traffic. But pack files are the appropriate way to configure clients for using a proxy, where in the top section of the pack file, you define all of those things that you should not proxy as direct. Using names, layer 7. There's, for Office 365, 40 domains. We have scripts published that can poll our published list of URLs and automatically generate pack files for you if you don't want to sit there and review it yourself. But in the top section, define direct to the Office 365 namespaces. For customers that, okay, but to allow you to go bypass the proxy, you also have to whitelist at layer 3 the outbound ACLs for all of the networks. That does not scale. There's over 500 CIDR networks. We are going to constantly add to those. If you are going into IPv6, you don't do that at all. So instead, yes, the second best option would be to proxy everything. However, again, the proxy should whitelist all of the Office 365 URLs. So when it sees the proxy connect and goes, oh, outlook.office365.com, I'll allow that without inspection or further interdiction.
So just to clarify, so you do not advocate bleeding, the Microsoft routes directly into the environment. Because if I do direct, I have to route the packets somehow. So they have to get somewhere, and they have to go out into the internet.
Right.
And that
So,
requires
so you do
routing.
not have a default out to the internet? You're only right?
No.
So that might be something where you could take advantage of Azure Express Route for Office 365. If you're running eBGP internally, then that's fairly straightforward. We also offer BGP community strings to help reduce that. But again, because there are over 500 networks, if you're doing OSPF or EIGRP or something like that, and you have to do route redistribution, it's too many networks to really do well. Your routing tables would be monstrous. So again, spend more on making sure your proxy infrastructure could support that at that point.
Excellent. Thank you.
But if you're eBGP internally, absolutely do route redistribution. We've got one primary ASN, a secondary ASN. You can stream it down to BGP community strings if you want to. There's 6, one for each of the major services.
Excellent. Thank you very much.
You're welcome. Yes, if you would just, because otherwise I have to repeat for the recording. Thank you.
Okay, so we are currently doing a pilot, but the pilot team is focused on IT because we want to test more of functionality. But as a part of that, the network team is absolutely worried about the bandwidth and the latency. So we have done a 1-week assessment with Microsoft, but we still need to use these Excel calculators. But our primary emphasis is Exchange Online. So do you mind either giving me a link or showing me what the Exchange Online calculator looks like, or I can reach out to the Microsoft account team?
So the Exchange Online calculator,
Yeah.
I mean, if you just did Bing, you can certainly find it.
Okay.
Of course, you're all watching me type, so I'm going to type very poorly. And the,
We don't see it.
oh, beg pardon.
Exchange calculator or the Outlook calculator?
The Exchange Client Network calculator calculates for Outlook. And magic. There we go. Exchange Client Calculator.
Okay.
You can download it from TechNet.
Okay, excellent.
It is, again, it's another XLSX. It's a workbook similar to what you saw in the Skype. We'll pull that down. It is still valid. The differences between Outlook 2010, 2013, 2016 from a bandwidth consumption are negligible. There is a new version that I hope will be published very soon. It's not yet. It's still going through some final validation. It's more focused on the number of connections differences, and there's a little bit of difference between MAPI over HTTP versus Outlook Anywhere. But in terms of the overall bandwidth consumption, if that's your primary concern, yes, it still works well, despite the fact that you may be using 2016 and it shows 2010 as the client side. And if we open that up. So same idea, you define your sites and your client mixes, your inputs go through, you've got personas, which we'll talk about as low, medium, high, extra high.
Yep.
If you don't have the baseline numbers to plug in,
Yeah.
then again, my guidance is always put everybody as user profile 4,
Got it.
which is very heavy. You can go in and increase those numbers to get a worst case scenario. It's a good way to start. But if you're Exchange on premises now,
Yes, we are.
and you're just migrating all your mailboxes to Office 365,
Yes.
the client traffic going into your Exchange on-prem environment
Yeah.
is being transferred to the Exchange Online environment.
Yep.
All other factors being equal, it's going to be the same amount of traffic.
Excellent.
So if you can evaluate that by net flows,
Yes, we will.
perfmon,
Yep.
top on the switch will at
Yep,
least give
yep.
you an idea, then you can just use that number to determine it.
Excellent. Thank you very much.
You're welcome.
Appreciate it.
But yeah, just client access calculator, download it. And of course, the latest link will be updated as soon as we release the next calculator. Last time I did this, there were questions for half an hour, and nobody's standing up. Somebody's got to have a question. Yes, sir.
Thank you for the information. That was very useful.
You're welcome.
Regarding latency, what would you say is an acceptable latency, roughly, and what is not an acceptable latency?
There are different numbers for different client performance factors. If you look at some of the tools that we publish, they're a bit more conservative than the numbers that I'm going to give you. But if you wanted a number to associate, Outlook to Exchange Online in cached mode, the latency value from when Outlook sends a request to when the CAS server that terminates the connection responds to the request, 325 milliseconds or less. If you must run in online mode, you have a VDI infrastructure, 100 milliseconds or less. For Link, Skype, whichever you want to use, I'm sorry, I keep using the old name because it's been that name a lot longer. For real-time audio, real-time video, 50 milliseconds is what I really try to target, but 100 milliseconds will give you acceptable performance. For instant messaging and presence, measure it in seconds. I use Skype on the airplanes using GoGo in-flight internet every time I fly, and you can see 3, 4, 5 seconds of latency. For IMs and presence, it works very well. But for audio, video, 50 milliseconds is what I would target. 100 milliseconds is still tolerable as long as it's consistent. You don't want a lot of jitter and certainly don't want packet loss. For anything being accessed through a web browser, again, you can probably measure it in seconds as far as would the web browser maintain the connection and function properly. But when you start looking at 2,000 milliseconds, 2 seconds, 3 seconds, users will begin to perceive a performance issue and complain. But if you're a typical network without any artificial latency latency by packet inspection, proxying, incorrect routing, etc., 325 milliseconds is enough time to go around the world twice. In a residential internet circuit in the United States, I can hit servers in Europe, in Asia, in India, 80 to 110 milliseconds on average. Depends exactly how far I'm going, what time of day it is. But I never see things spike above 150. And for Exchange Online, I've got that 325 millisecond threshold with cache mode. So those are really good. More important than anything else is how long does it take to do a DNS resolution? Depending upon whose book you read, you'll see somewhere between 50 milliseconds and 25 milliseconds. I always want to see that number on the lower end. So fast DNS resolution, because the DNS server is in the same site as the user. If it's the very first time a name's being resolved, sure, it's got to recurse out to the internet, hit root, find the NS, pull the record down. But if it's a local server with local egress, that's still going to be under 50 milliseconds. But if DNS is very slow, because you don't have a DNS server in the same site as the users, or the DNS server they're querying has to then forward to another DNS server on the far side of the WAN, every one of those DNS resolutions that takes long is going to pile on top of itself to add to the overall time. In Office 365, we use very short TTLs because we are constantly rebalancing services. We want to ensure that if there are vagaries with internet connectivity, heaven forbid there's a site disaster, we very quickly get all clients connected over to one of the other nodes. So you're going to see lots of DNS queries. Fast DNS resolution is very, very important.
Thank you very much.
You're welcome.
I got one.
Yes.
So a lot of people talk about Exchange Online and Skype, but we have unified messaging, and our customers call in when we'll leave voicemails for our member service reps. What kind of performance do we need to make sure we have crystal clear voicemail?
So when you're playing the voicemail back,
And recording it, right? Because if it's going to traverse the SBC across the internet to Exchange Online.
much like streaming audio and video, I would target 50 milliseconds, but up to 100 milliseconds should be acceptable. More important is going to be any jitter, any lag, any case of packet loss. Those would all be things that would impact the overall quality of the recording and therefore the playback. There are a couple of calculators, and based on your accent, I'm assuming you're US based.
Yep.
Have you seen the Fast Track network analysis tool?
Not yet.
Let me see if I can pull that up real quick. I probably won't be able to run it because I'm not going to have admin rights on this machine. And it does require Java, which I seriously doubt has been installed. But the fast track network analysis. Yes, so the Office 365 Fast Track Network Analysis tool, and this is the North American one. It does require Java. But if you have Java on a machine, you can download this Java app that will do a series of calculations against your endpoint. It'll evaluate upload, download speeds, ports open, round trip time for services, packet loss, jitter, lag, and provide you a profile of quality and evaluate where you are in the overall thing. But under 100 milliseconds should be okay. 50 is what I would target. Really, if you're above 50, odds are really good there are things you can do on your network or working with your ISP to bring that number down. One of the most important things you can do is ensure that your ISP peers with us. So we've got 60-some different points of presence throughout the world. We will peer with any ISP who requests it. We've got very, very minimal requirements, just the number of prefixes they can support, that they've got 2 ASNs. I mean, mom and pop ISPs can meet those requirements. If they peer with us, that means that as your traffic egresses your network, goes through their network, instead of going from them to a second tier to a third tier, routing half a dozen different ISPs to get out there, they meet us in a Meet Me facility, maybe an Equinix Colo or other exchange point. So they go from their network to our network very, very quickly. If your ISP peers with us, you'll greatly reduce that overall latency from your edge to ours, because instead of 17, 18 hops, you can get to us in 5 or 6 hops.
So is there a list of the ones that are peered? Because I know ExpressRoute makes that part even faster, but of the ones, without ExpressRoute, the ones that are already peered, like
Sure. So if you go to
level 3 or-
Microsoft.com/peering, you guys can see that, right? So the peering database allows you to do queries. You can send your ISP to the peering request page. They have to ask us. You can't ask us. We can't ask them. They have to ask us. But it's minimal requirements. But in terms of the peering database, this takes you a direct link to the peering database for our ASN, and you can see all of the various locations where we peer and all of the various ISPs that we already have peering relationships with. And if your ISP is not listed there, talk to them about getting into us, because we try to be as open and as easy to deal with as we possibly can be, because it's in their customers and our customers, your best interest if that peering happens. So, I mean, we'll peer with anybody who asks, but it's the ISP who has to ask them, so they're the ones who have to do their side of things.
Cool. You should lead with the fast track thing next time.
But then what would I do with the last 10 minutes? Yes?
So if we are going to be doing TLS inspection for all traffic, is there anything specifically I need to ask our InfoSec guys to make sure they're prepared? Like, you need a Blue Coat XYZ model or higher for 10,000 users, or do you have a recommendation?
When you look at any specific proxy model and their supported number of connections, they are providing you numbers based on web surfing, which is very asynchronous, lots of short-term connections that close very quickly. Do not use those numbers. Talk to your vendor specifically about, we're going to Office 365. We have 5,000 users who are going to be connecting to Exchange Online. Those same 5,000 users are going to use Skype for business, and we want to do audio, we want to do video. They'll get an engineer who can help you scale. As a general rule of thumb, start thinking you're going to be 2 models up above what you would do if you were just thinking about web surfing. The biggest concerns with TLS inspection are the number of calculations for the number of sessions. So a proxy that's just going to do endpoint evaluation and let HTTPS traffic go out unmolested All it's got to do is look at those 3 connections per user per mailbox, see they're all going to Office365.com, whitelist says allow, and it goes. If you look at it from a packet trace level, you see the client connect to the proxy, use the HTTP connect method to punch a TLS tunnel through the proxy, and done. If you want to do TLS inspection, first, that proxy has to generate a certificate to terminate each of those sessions. Your Windows managed devices, you can push the root certificate out through GPO. Non-managed devices, you've got to get the root certificate off of the proxy out there somehow. But for each one of those sessions, it's got to first terminate the TLS, so at least 3 connections for you to get to your mailbox, so they can do the inspection. But then it's got to reestablish TLS to us, so that's 3 more sessions of TLS. So you are burning 6 TLS sessions that are persistent from the time you log on to the time you log off. If that proxy device has a pool of 10,000 connections and it starts to deplete those connections because of all the traffic that's going through it, it's going to start to do things that are making performance really bad, like closing those connections. Again, the default's normally 120 seconds. We're going to expect those connections to be persistent. There are a couple things you can do. You can push a registry key that tells our clients to do keep alives, to keep the connections open. But all that does is use more bandwidth and generate more traffic. Instead, you should configure the proxy not to time out in 2 minutes. Say keep it for 5 minutes, because you're always going to see traffic in under 5 minutes. But you also want to take a look at how the proxy's handling that load. Processor may be okay for all of the calculations, but keeping track of all the connections may start to use memory. One of the performance issues we see very often with proxies is that TCP scaling factor. A TCP scale factor of 8, we can move dozens of megs of data before we have to stop and do an ACK. You cut that down, they're by order of magnitude. So from an 8 to a 4, from a 4 to a 2, some proxies will just start at 0. If the TCP scale is 0, then you've got the effective throughput from back in the early 90s. And okay, hey, I've got a 100 meg connection. Why does it take me 15 minutes to download a 30 meg file? Because you've got a long way to go, you've got a lot of latency, and we're having to transmit a packet and get an ACK every 2 or 3. So keep an eye on those as well.
Okay. And can you also restate I think you gave the number of NATed IPs per 1,000 users you recommended?
For conservative, you've got some legacy clients out there that need more connections. 2,000 users per IP address assigned in the NAT pool. If you are all modern clients, 2013 SP1, 2016 Office Pro Plus, 6,000 to 8,000, depending upon which services you're going to use.
Okay. All right, thank you.
You're welcome. Yes, sir.
When these Excel sheets can pull the user profiles from
I'm sorry, I can't hear you.
when the Excel sheets can pull the user profiles from the living environment, so that we don't need to guess what are the user profiles.
I'm still having a hard time understanding the question.
The Excel sheets.
The Excel spreadsheets.
Yeah, when they are pulling the user profiles from the living environments, so that we don't need to guess what kind of profiles we have.
Because no 2 customers are going to be exactly the same, that's a pretty tall order. You've really got to provide some information on the Excel calculator. If you look at the pre-configured personas, they may be heavy or light. That very heavy for Microsoft is actually our light user. We would calculate a much higher value, but we're very heavily in email. Big surprise that. They may, however, be on the opposite side and grossly overestimated for you. So there's a limit to how we can average things out versus what's unique about your users and sometimes your personas or your departments.
I think your question is about having the calculators pull data from your live system or the existing data to build a profile for you instead of the admins having to populate it.
Yeah.
Yeah. It's a good question. It's a valid question. I don't know how that would do that because, I mean, Excel doesn't have a way to query perfmon. You'd have to get some kind of perfmon. It's something I can suggest to the team as a request.
Yeah, but on the Skype and Link, you have reports, and on Extends, for example, you have a lot of traffic information. So
It's on my list, respectfully.
good.
I'm not sure when, but it is something.
And he's the program manager, so if it's on his list, that's where it needs to be.
That list might be quite long.
But I'll pass that along for the Exchange team. Say, well, the Skype team's thinking about doing it. We'll see how that goes. Anybody else? 5 minutes to spare. That's amazing. I usually run way late. So those of you stuck till the end, thank you very much. Have a great rest of your conference. Oh, yes. Sorry, one more thing we got to do. Back to the slides. Where'd they go? Yeah, so that was the questions. A couple things. There's some links. Certainly you want to take a look at Fast Track. It's not showing. Well, it's supposed to be. All right, we'll do it this way because at least that way everybody can see it now. So fasttrack.microsoft.com. The Fast Track team provides great service and support to help with implementation and migration. They've got some great team members there who can help you through your technical issues. There's also the tech community, which you can join. That is like other communities, like-minded people like you who are looking to go to Office 365. We often do customer-facing presentations there. There's a customer advisory board capability there as well. And of course, please make sure you do your evaluation. That's how we figure out whether these are hitting what you want, determine what comes next time. So again, thank you very much, everybody.